Hi everybody, Callan Bentley from Piedmont, Virginia Community College. Getting close to the summit of Old Rag Mountain in Shenandoah National Park. And most of the rock that we see here is granite, specifically the Old Rag granite, which has been dated at 1.04 billion years old, using the uranium lead technique on zircon crystals in this granite. There's not a lot of zircon in this granite, but there's enough that we can date it. But one of the things that you'll notice as you hike Old Rag Mountain is the very rounded form of the mountain. It's like a series of granite domes. And if you look over here, you can see something that looks almost like a pile of potatoes, all right? These big rounded boulders. One of the things that a sedimentary geologist is very aware of is that the further a sedimentary particle travels away from its source, the more tumbled it gets, and the more its shape goes from angular to rounded, and even well-rounded, like an Easter egg. But there's a bit of a conundrum here because these boulders are almost exactly where they started off, and yet they have that rounded form. So what's going on here is a separate issue, all right? It's not tumbling down some ancient river system. This is what we call spheroidal weathering. And spheroidal weathering is just basically a phenomenon that occurs when weathering, chemical weathering, attacks the rock, and it basically destroys the rock from the outside in. And what matters here is when you have a sharp angular corner to your rock, there's a lot more surface area there for chemical weathering to attack. And over time, an initially angular block will become increasingly spherical. So that's one of the neat things that you can see here are these in-place spheroidally weathered boulders. But if you get up on top of some of the boulders, you see these features. There are these things that look almost like little potholes, but these are not potholes. They were not carved by a swirling vortex of river water. Instead, these are little solution pits, and they have a great name, a German name called Opferkessel. So what happens here is you'll get a little concavity in the surface of the rock, like this one here, and then that little concavity catches rainwater and holds it a little bit longer, whereas it runs off of little high areas on the outcrop surface. And because it holds onto that water for a little bit longer, there's a little more chemical weathering that happens there. So specifically the feldspars are rotting a little bit, turning into clay. Another thing that'll happen is if it gets cold, then ice crystals will form. And those ice crystals will find their way into little cracks in the rock and wedge them open, because ice takes up a little bit more room, about 9% more volume than does liquid water. And those two processes kind of working together over and over will take a small initial concavity and enlarge it through time. And as these things develop, you'll see that they get sort of this overhung lip. So the Opferkessel basically works its way underneath there. And then they start to develop like sediment. So there's like sediment in there that's basically coming directly from the weathering of this granite. I suppose there could be a small bit that gets blown in by the wind, but most of that's produced on site. A little bit of organic material in there too. And sometimes these have interesting ecologies. Like as I'm looking in this one here, I can see some little tiny worms squirming around in it. So they're neat little worlds unto themselves, these Opferkessel. Sort of the opposites of islands. They're little ponds in the sky.